1 over. We'll do that up there. But even more basic than that, negative powers are dividing. So this is alpha divided by alpha, which is 1. Now we'll do the 2 other ways up here. So the other one would be 1 over alpha, which is what we heard back there. What's 1 over alpha by alpha? 1. You could say it's alpha over alpha, which is 1. The other thing you could do is alpha to the minus 1. Could you write alpha as a power? Alpha to the 1. What happens when you multiply like powers? Alpha to the power minus 1 plus 1, which is alpha to the power 0. Anything to the power 0 is? 1. So whatever way you look at it, this yoke would be 1. The way I would say it is I got 1 plus x squared, and the negative power means divided by 1 plus x squared, which is 1. So they're gone. And that means that I don't have a mixture of w and x, and I know that it's worked. So we've done the w substitution. It should replace it by something easier. Does this look easier than the original? Yeah. Yeah. So now we go back to the tables. Is this in the tables?
Yeah.
Yeah.
E to w is
there.
E to w.
Antiderivative e to the w is e to the w. And then we should go back in terms of x. The w was inverse tan of x. And plus the c. I'll do one more. So sine cubed by cos x. Okay, this one is going to talk about manipulations, but we're going to do it with a substitution. I'll just talk really briefly about the manipulations. So what you can, okay, so there's a few things you have to understand. The sine cubed means sine of x all cubed. And there are, what the hell am I going to write here? Okay, it's not in the tables. Okay, there are 2 possible manipulations. Oh yeah, one of them is you can write sine x cubed as a sum, but you don't know that one, so it doesn't matter. Multiply it by cos. It's a good blah 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 blah. We won't do that. Instead, we'll rewrite the sine cubed. So what we're looking at is actually k, this yoke, is antiderivative sine of x cubed by cos of x dx. So we've got, can we see in here a function and a multiple of its derivative?
Sine of x is cos of x. So
yeah, so you got function sine of x, derivative is cos, so this should be your w. That's the very clever way. And the easier way is there something inside something else? Sine of x is inside
power 3.
Power 3. So we should let the w be sine of x. Okay. So we'll let w be sine of x. And we'll rewrite this thing. So this k will be w cubed that's the first bit, and then you the cos x just sits. And you rewrite the dx in terms of dw by differentiating w. So we w is equal to sine of x. So we differentiate this. What is the derivative of sine of x?
Cos of x.
Cos of x. Multiply both sides by dx. Get dw is equal to cos x dx. And I think last semester, when you saw the cos x dx and the cos x dx, you would just put in the dw. Now it would have been a u, but I really think it's better that we use this w because there's going to be other u's in a second. better to have them separately. So you can just put in the dw now if you want, but I kind of always do it this way. Replace the dx, so divide both sides by cos x.
Can you just say why you're doing the dw dx again there on the right?
Why?
Yeah.
So what I wanted, I'm trying to rewrite, I'm trying to change from x, all x's, to all w's. So I have to pick this one thing to be the w. So really, the simplest thing you can say is that it's inside something else.
Yeah.
That's your w. So start rewriting this thing. So this is w cubed. Now cos x is cos x.
Alright.
Can't say nothing. I need to write dx in terms of dw. And to do that, I need a relationship between dw and dx. We will need to do this in the next section as well, so there's no harm seeing it here. So how do we get the relationship between dw and dx? Is you differentiate w. You'll get dw dx, which means differentiate w with respect to x. Differentiate w with respect to x, differentiate sine x with respect to x. Are you okay to hear? So now we have this relationship between dw and dx. We can solve this. Now actually doing this is nonsense. Like you can't multiply by dx, it doesn't make any sense, but it gives you the right answer. So if you're trying to solve this for dx, what I would do is, I've got divided by dx, so I multiply both sides by dx, to be gone there, and I have cos x by dx. And I want to get dx on its own. How do I get rid of that and multiply by cos x?
How do you what?
I want to get dx on its own
By divide.
by cos x. So I'll divide both sides by cos x, so I end up with dw divided by cos x, and cos x dx divided by cos x is just dx. And now this dx, which we had here, is now dw over cos x. And then if the substitution works, a nice thing happens. Does it happen? Yeah. Yeah. Cos x divided by cos x is just 1, so that's gone. So we have w cubed so the w substitution has worked. We've got a simpler antiderivative. So you go back to the tables. Is that in the tables? Yeah. Are the antidifferentiated power?
And plus 1 over...
Add 1 to the power. And divide by nu. And it's asking with respect to x, so you put the w back in. So you get sine of x, which is the same as w to the power of 4 over 4 plus c. And if you differentiate this, you will get this. Okay. Right. So all of that technically you have. And now we're going to give you a new technique, which is integration by parts. Now in week 13, which is, so we've got tonight, after Easter, and then week 13 the review. I'll go over last year's exam paper. Now I don't really give exam hints, what I can tell you is, if you look at the exam papers over the last few years, these are the patterns. This is what you can be guaranteed, and you can be guaranteed that there will be a question on the exam paper and integration by parts. So this is new.
Is this new for the example?
No. So integration by parts. So you can say, so there's a kind of a thing now. You can say, okay, we're doing all this antidifferentiation for calculating integrals or whatever. You can kind of turn around and say, but sure, like I can do that using mathematical software, and that is true. But there are other things in level 7 and into level 8 where the software, you have to do it by hand, and this is one of these things. Or like if you want to have any idea where it comes from, you need to see this. Okay. So this is now a fourth technique. If all of those things have failed, and all the ones will do it like that. So tables, manipulation, W substitution. If that fails, integration by parts. All right. The chain rule for differentiation leads to the substitution method, which was this what we call the W substitution method. And the product rule for differentiation gives us another integration technique, an antidifferentiation technique. So if we write down the product rule, this would say if you differentiate u times v, you will get the first thing u by the derivative of the second thing plus the second thing times the derivative of the first thing. So the question earlier, can you do all products with the W substitution? No. This is another way you can do some products, you can't do all. And what you do now is you take away v du dx from both sides. Well, what can we do? Let's just write down a formula. So if you antidifferentiate this, with respect to x, you will get uv.
You know, when you say this is part of the strategy, is this the one that will pretty much work for everything? If not?
No. Sorry. Okay, so I'll give two answers. So there's nothing that will work for everything.
Because
Not everything can be done.
But this one will
In the
work.
context of this module, you will have one on the exam paper that needs this,
Okay.
and they will have one other strategy as well. Well, it'll be a special manipulation.
Can you use this in all the ones you've done previous? No.
No, none of them.
You can't.
It won't work. It's like if you think about it. So you want to do it the easiest possible way.
Okay.
So the first is from the tables, the second is the manipulation, then a W substitution, then this. So this is like a fourth chance,
Okay.
really, or you will get one. So like there's ones later on where you can do a W substitution and it's quicker, but it's longer but easier to multiply out through manipulation. So this would be the fourth thing you should try. Now obviously if you do a lot of stuff, you kind of start to recognize, but you're not going to do a lot of them. So you're going to know that on the exam paper one of them will need this, and it should be, I'll explain later on to tell you how you'll know. So you do a bit of manipulating around, you end up with this formula. I won't explain exactly what this means, but basically you get it from this. So you get this formula. So when you need to do integration by parts, it's in the tables, it's also on the exam paper. I think on the same page that it's required. So you try manipulation. It's not in the table, it's not a manipulation. W substitution is going to work. You need to do integration by parts. You write down this. So there's, okay. Now we won't explain it fully, we'll do it more in examples. But what you do is so this is what you're working with. And like the W substitution, it just gives you, it actually splits it into two. I suppose that's why it's called parts. This part, that part. I don't know if that's right, but anyway. And usually this one will succumb to direct from the tables, manipulation, or W substitution. So you've got what you're trying to anti-differentiate, or what you're dealing with, is this antiderivative u dv. So you pick something to be the u, and everything else is the dv. Now, how you pick the u, you use something called liate, which also can help you pick the w in the previous section. So liate is, and I will explain maybe after an example or two why it actually works. So the liate, L stands for logs, I is inverse trig. You will almost certainly not get an inverse trig. So actually the second one, which was really difficult, if you did the liate to that, so there was an e to the inverse tan and a 1 plus x squared. There was no logs, there was an inverse trig. You should pick the w to be the inverse tan inverse. You won't see this. Algebraic, I'll explain I should explain what all of them are. So logs is ln of x. Inverse trig, you almost certainly won't see, is inverse sine of x, inverse tan of x. Algebraic means x squared, x, stuff like that. And if you use this for the W substitution, if there's a tie between like this, if there's a tie between the two algebraics, you pick the higher power to be the W. Then trig, trig is sine and cos. And then this is e to the x. So you pick u to be the first thing on this list that you see, and everything else is the dv. Okay. Okay. So calculate this, find this. So in the exam, you won't be prompted to use integration by parts. In Math 6040, once you see all the questions, it should be clear that this will. So you'll have a question on your exam paper that requires integration by parts. Something like this can occur in part A or part B, and once we finish by next week, you'll kind of know that this needs integration by parts. Now, otherwise, say if you didn't and you went through the big strategy, the first thing you do is you say, is it in the tables? Now, you can't really use the tables because although the 5t is in the tables, and although the e to the minus 3t is in the tables, why can't we antidifferentiate directly? Because they're multiplied together. If they were added together, you could do them separately, but they're not, so you can't. The substitution, there's actually, in terms of the first way where you say function multiple derivative, there is no possible substitution because if you try, now you could do w is equal to 5t, but you end up with something that's no good. You're still stuck. You'll get like w e to the something horrible with w. You could say, so that doesn't work. You could say the minus 3t, but you haven't got a multiple of minus, you've got an extra t, so that won't work either. So basically w substitution won't work here. So if you're in the wild, like, so if any kind of yoke, if you didn't know what was going to come up, you could try w substitution, it won't work. You'll get to here, you're stuck, there's no more w substitutions to try, there's no more manipulations, it's not in the tables. Now you try integration by parts, but it's easier to do the integration by parts here. Okay, so integration by parts is what we have to do. So we write down our formula, and this is what I recommend that you do, write this down. U dv, as I said, this formula is in the tables, it is also on the exam paper. uv minus v du. So this is like our v du. Now just be careful, this is like our u dv, careful. The first thing isn't necessarily the u, which we'll see in a minute. So the thing that we're actually trying to antidifferentiate is the UDV, and this thing can write it. It looks more complicated, but actually, usually this thing you can antidifferentiate. So the thing is to pick the U by the ate. Are there any logs in here?
No.
No logs. Inverse trig, you're not going to see them. Algebraic, are there any algebraic in here?
Minus 3t, the problem is
The minus 3t is a perfectly correct answer, but if you look at the u, yeah, the 5t, is the minus 3t multiplying? No, the 5t is. So this should be your u. And everything else is dv. There it said by the ate, we have no log, no inverse trig, algebraic, yes, 5t. Minus 3t doesn't do the job because it's not multiplying, 5t is algebraic. Because it's like x. Right? Okay. So what we have to do is use this formula. So we've got this 5t e to the minus 3t, which is our udv, equal to u. We have u. Question. How do we get v.
Differentiate u minus 3 by
Differentiate
integrate.
antidifferentiate. So v is the antiderivative of dv. We'll explain that particular line probably after the break. So this is antiderivative dv is e to the minus 3t dt. If you have tables about, is that in the tables? Yeah, it is. Now I will leave that there for a second. It is in the tables. So we're going to have v after the break. We still have v after the break. How do we get to u?
You differentiate u.
You differentiate u. So you pick the u and the dv. You differentiate this, antidifferentiate this. So we're going to write du dt. What is the derivative of 5t? 5. I'll slow it down. I'll fix the 5. And what is the derivative of t with respect to t? 1.